What's up guys, MizzoFrizzo from Pitchfork Academy here, and in this Unreal Engine 5 tutorial I'm going to show you how to set up a very basic damage and health system, including damage to specific limbs. So if I shoot this guy in a specific limb, you'll see up the top left it says torso 80, torso 60. I could shoot him in the leg, it will say right leg, left leg, and show the remaining health of that limb. And if this guy gets to 0 health, he will ragdoll and die like so. And if I hit play again now and I go over and shoot this guy in the head, if I can actually aim, I don't have a crosshair here, you'll see that he will die because the default health of the head is set to 20 and I am causing 20 damage here. So you can set this up to execute any kind of logic you want. For example, if I shoot his leg and I get his leg health down below 60, you could cause this character to be injured and start limping or something like that. You know, you could cause damage to the arm and cripple his arm, and then aiming would become much harder, so on and so forth. But this is just the basics of this system, how to add a component to these characters that is a health and limb damage system that stores the health of each limb. And like I said, with this example of a headshot, it is executing specific logic based on that limb being hit and its health reaching a certain point, in this case 0. But as per usual guys, just before we get started, if you like what we do here at Pitchfork Academy, you can support our channel by wishlisting our upcoming game, Skyblocker, which releases on Steam April 16th. But without further ado, let me show you how to do this. Alrighty guys, now I'm here in my template project and all I've done is import a few animations and weapons and basically set my character up to be a kind of third-person shooter setup, as well as playing an animation on my pistol when I click the left mouse button. Now this is not a weapon system tutorial, but if you need any help setting up any stuff like that, I have plenty of videos on the subject, so I highly recommend you check those out if you haven't already. But basically what I'm going to be doing is starting this tutorial off by drawing a line trace from my weapon, and that's going to be what we use to cause damage on the other character. So the first thing I'm going to do for this line trace is set up a new trace channel. I'm going to go to Edit and Project Settings, search for Trace, and add a new custom trace channel here. I'm just going to call it Bullets. I'm going to leave the default response as block and hit accept. I can close the project settings now, and the other thing I want to do is basically stop the capsule component from blocking this bullets trace because it's going to need to hit the actual character mesh here. So I'm going to select the capsule component. I'm going to find the collision settings right here. I'm going to drop down the collision presets, change it from pawn to custom, and I'm going to change the bullets trace to ignore, like so. So that means that the bullets trace, because we set the default response to block, it will be blocked by absolutely everything in our project except for the capsule component on our master character class here. So now that I've done that, I'm going to head back to the event graph here and I'm going to do a line trace by channel. I'm going to draw this from the muzzle of my weapon, but I might also show you how to draw it from the camera, just in case you want to do it that way. So I am going to use my weapon here, this skeletal mesh component that I've created, which is my weapon. But just before I set that up, what I might do is just get the player camera manager, and I'll get actor transform, split this struct pin, plug the location into the start point, get the forward vector of my camera, multiply this by a float, so right click on the pin here and convert this to float double precision, and I'll just make this something like 50 meters, so 5,000 units. and I'm going to add this to the location, add to the location, and that will be my endpoint. So basically what this has done is got the camera's transform, and wherever the camera is where my line trace will start. And then the forward vector is basically a 1 unit vector in the direction that the camera is facing, so a 1 centimeter vector. So I've multiplied that by 5,000 to get a 5,000 centimeter vector pointing wherever the camera is looking. And I've added that to the location of the camera to find the endpoint. I'm going to change the trace channel to bullets, and I'm going to change the draw debug type to for duration. And trace complex, sure. And now that should be working. So when I shoot my weapon here, it is just drawing a trace straight forward wherever the camera is pointing. And this is more than enough to test this setup if you want to use this line trace. But what I'm actually going to do is draw the line trace from the barrel of my weapon. So how I'm going to do that is I'm going to browse to my weapon, and all of these weapons are available in my Mega Sample project, which is available via my download 1800 free animation assets video. But right here I've got my Pistols B and my Pistols B skeleton. This is the weapon that I'm using, and in my Pistols B skeleton you'll see that there is this socket called muzzle flash, which they use to spawn the particle effect for the firing animation. So this is going to be fine to draw my line trace. I can basically just single click on muzzle flash and Control C the name there, and then right here in my third person character I can, off my weapon, get socket transform. In socket name, I'll paste in the socket name muzzle flash, and then I can right click and split the struct pin here, and I can literally hold Control and click and drag these onto the location, hold Control and click and drag this onto the rotation, and then I won't be needing the camera stuff anymore, using my sockets transform instead. So now if I hit play, that trace is being drawn from the barrel of my weapon straight wherever the weapon is pointing. Nice. Okay, so the line trace is basically just a way of us to interact and cause damage to another player. This could be anything. It could be a sphere trace from a melee weapon. It could be an explosion, you name it. But this is just what we're going to set up today to demonstrate this system. The next thing we want to do is apply damage to the hit actor. And basically what I'm going to do is add a tag to this character class, and will only cause damage to actors that have that tag. So if we select the root here and we search for tag, we can find actor tags right here. We'll add a tag, and I'm just going to call it human. And now that we've done that, we can drag off the return value of this line trace and press B to get a branch. And then I'll also drag off of the out hit here and break hit result. I can drop this down, and this is all of the data that the hit result from our line trace can give us. I can drag off of the hit actor right here and find has tag, actor has tag, and I will type in the tag here that I just set, human. And I'll also drag off the return value here again and press B to get a branch. And now this will only execute if we hit something, and that something has the tag human. Nice. The next thing I want to do is drag off of true here and find a node called apply point damage. And this is very, very handy. It's replicated by default, and it allows you to pass across some very useful data for a shooter game. So hit actor right here will go into damaged actor. Damage causer right here will be self, so we can get a reference to self. And event instigator is a player controller reference. We can get player controller just in case we need that later on. And I'm going to change the damage type class to just damage type. Hit info right here, we will pass through the out hit from the line trace to hit info, and hit from direction we can pass through the trace start. And I'm also just going to set the base damage as some arbitrary number. I'll just call it 20 for now. We can collapse this now. That's everything we need from there. And that will basically, this will cause an event in the damaged actor called event point damage. So if we call this node now event point damage, whenever this is called, the damaged actor, if it has this node inside of it, this node will be called. So this doesn't have to be the same character class here, but you can set all of this up in a sort of parent class, and then any children of this class will inherit all of this functionality. So I would recommend just setting it up in the parent class like so. What we might do now is create a Boolean to check if this character is still alive, because we don't really need to execute any of the code after this if that character is already dead. So let's create a variable. I'll call it alive question mark of type Boolean, hit compile, and then change the default value to true like so. And I'll get alive here, drag off of here and press B to get a branch, and then we will only execute this code if the character is alive. Now, you could just do your health logic here on this event, but what we're going to do is actually make it part of a component so that you can add it to whatever classes you want. You know, it doesn't necessarily have to be a child class of third-person character. It could be some type of animal. It could be, yeah, anything in your game that isn't one of these character classes. So we'll put it in a component, but just before we do, let's go ahead and create the physical materials that we'll use to do our limb damage. So if we go to edit and project settings and we search for physical, you'll see physical surface right here, and we've got the default surface type and then a bunch of custom surface types here. So here you can create custom surface types such as concrete, glass, you know, you name it, and you can have behavior in your game based on these surface types. But we can also use this to differentiate sort of where on a character they have been hit and what sort of damage to cause, and you know what logic to execute because of that. So here we're going to create a few custom surface types. The first one will be head, and we'll do torso, left arm, left leg, and right leg. Nice. And that's all we'll need for today. We can close these project settings now, but we also need to create corresponding physical materials with those surface types. So we'll go to our content browser. I'll right click, create a new folder, call it materials. And in materials, I will right click, create another folder and call it physical materials. And in physical materials, I'll right click and I will go to physics, physical material, create a new physical material, just select physical material and hit select. And I'm going to call this PM underscore head. I will duplicate this. I'll call the next one PM underscore torso, and so on and so forth. PM left arm, PM right arm, left leg, and right leg, like so. Nice. And now we just need to open each of these and set the corresponding surface type in each one. So we'll open head, and right here under surface type, you'll see the custom surface types that we've just created. So I'm going to set head as head and close that one. Left arm as left arm. Left leg will be left leg. Right arm, right arm. Right leg, right leg. And torso as torso. Nice. I'm going to hit save all now because we've done quite a lot, and I can close all of these physical materials. That's literally all we need to do with these. is set those surface types within the physical materials, and then what we can do is set anything basically we want as this physical material, and it will then be of that surface type head. So we can do that in the physics asset of our character. If we head to our third person character here and look at the mesh, over here you'll see the skeletal mesh asset is SKM Mani. We can browse to that, and then if we open the skeletal mesh of whatever skeletal mesh your character is using, we can open that, and then down here in the asset details, you will find the physics asset. And right here, we've got physics asset underscore mannequin. We can browse to that and open that, and you'll see that it has all of these physics bodies. And basically, we're just going to set the physical material of these physics bodies to whatever we want them to be. So I'm going to start at the top and work my way down. We've got the head, but we've also got these two physics bodies in the neck. And I feel like neck 1 is a little bit too low to be a headshot if you happen to hit this one, but I'm going to make it neck 2 and head. So over here in the skeleton tree is an easy way to select multiple. I'll select head and neck 2, and then in the details panel here, you'll see on collision we've got phys material override. We can change the physical material override of these physics bodies to our PM head. And we'll do that for all of these physics bodies. So let's do the torso next. And I am going to select neck 1 as part of the torso. And then what I might do, actually I'll select pelvis all the way up to clavicle L. I'll also hold Control and click clavicle R and neck 1. And these will be my torso. So right here, physical material override, I'll find PM torso, select that one, and then upper arm L down to hand L will be my left arm, PM left arm, upper arm R down to hand R will be my right arm, and thigh L down to foot L, PM left leg, thigh R down to foot R, PM right leg. Nice. And now if you select any of these physics bodies, you'll see the physical material override has been set over here. Each of these physics bodies has that physical material and therefore has the corresponding surface type, and we can use that to dictate our logic. Nice. We can save this and close this and head back to our third person character. We can close the skeletal mesh as well. We're not going to need that anymore. And the pistols be skeleton. And now what we're going to do is create a health component, which we will add all of our limb damage and health logic to. So like I said, you won't just have it in your third person character. You'll be able to add this component to, anything that you want. So in content, I might right click and create a new folder and call it blueprints. And in blueprints, I might create another new folder and call it actor components. And in actor components, I'll right click and go to blueprint, blueprint class, and create a new actor component. And I'll call this AC underscore health system. Open this up, and we're going to need a couple of variables in here. The first one will be total health, so I'll just call this total health, and it will be of type float. And next we're going to do our limb health, which we'll store in a map. And this is very, very handy using the enumeration of the physical surface, the custom physical surfaces that we've just created. So we can create a new variable. I'll call it limb health. And right here, I will search for E physical and find E physical surface. And then I'll also in the details panel drop this down right here next to the variable type and change this to a map. And the second variable in the map here is going to be a float. Now, don't worry if you haven't messed with maps before. They're pretty easy to wrap your head around, and this will be a good introduction for you. So I'm going to compile this now, and if we look at the default value of our map here and add an element, you'll see that basically there is an enumeration, and this first column here is called the key, and then this second column is called the value. So this right here is the key, and this right here is the value type. And if you drop down this enumeration, you'll see that you've got all of our custom physical surfaces here that we've created, which is very, very handy. So what we can do is basically set default values for each of these. So I'll select head, I'll add another one, and I'll select torso, add another one, left arm, right arm, left leg, and right leg, like so. And now we can set default values for the health of each of these limbs. So I'm going to make it 100 for pretty much all of these, but just for the purposes of this tutorial, and maybe you want to do it as well, I'm going to set the value of the default value of the head health to 20. And I'll show you some very simple death logic because we set the damage to 20, it's going to take 20 health off the head, so it'll be a one-shot headshot. So anyway, you don't have to set it up like this, but I do think this is very, very handy, this setup, so that's the way I'm going to do it. The next thing I'm going to do is create a new custom event in my health system actor component here, and I'm going to call this custom event event any point damage, like so. I'm going to pass through an input here called damage of type float, and I'm also going to pass through the hit result of the line trace. I'll call it hit, and I will search for hit and make this type hit result, like so. Very, very nice. So just before we set up all of this logic here, I'm going to make sure that I add this component and call this event in my character. So I will compile and save this component, and then in my third person character, I'm going to add AC health system component, like so, and I'm going to control click and drag this out and get AC health system, and I'm going to call that event any point damage on true here, and I'm going to pass through the damage and the hit info, like so. Now you could pass through more inputs if you need them for your logic, but for the purposes of this tutorial, I'm just going to pass through the damage and the hit result. So now that we've made sure that we're calling that event and we've added that component, I'm going to head back to the component and start setting up some functions in here. The first one I'm going to create, so I'll create a function and I'll just call it update total health, like so. So this will require one input. It will be damage of type float. And what I'm going to do in here is just essentially update the total health of my character. So I'm just going to set total health here, hold Alt, click and drag this out to set total health. And it's going to be total health, so hold Control and click and drag this out to get a get. And I will get a subtract node and subtract the damage from the total health and then set the total health as that. And what I might actually do is just clamp this, clamp float, and I will clamp this between 0 and 100, which is going to be the default value of my total health. And before I forget, let's set that default value. So select total health and set the default value as 100, like so. You don't have to do it this way, but I'm going to set it to 100. And also, let's just while we're here, set this up to call a death event on our character if our total health gets to 0. So here, I will get a less or equal. And if it's less or equal to 0, I'll drag off of here and press B to get a branch. If it's less or equal to 0, we'll call a death event dispatcher. So I'll create an event dispatcher here. I'll call it on death. And I'll drag this out and call on death. And then what we can do is we can bind this on our character. So we'll do that later. But basically what this is going to do is send out a message to anyone who's subscribed to this event dispatcher. And we can call an event on our character that causes death. Nice. Now that's it. That's all that's required in this update total health. Let's go back to the event graph and just call this update total health right here and pass through the damage like so. And just to check that this is working, let's grab a print string and I will just plug total health into the in string right here. And I'll make this yellow so it's a bit easier to see. So we'll just print our total health after this update total health function has been called. We can compile that, and I might just hit save all just in case. And I will grab the third person character from third person and blueprints and drag him out into the world. And this will be our test dummy. So if I shoot this guy, might be a bit hard to hit with the setup that I've got because I don't have a crosshair or anything. But you can see up the top left, it's printing 60, 40, 20, and 0. And then 0, 0, 0, 0. So that is still printing because we did set up this alive Boolean in our third person character, but we're not setting it at all. So let's quickly bind to that death event and set this Boolean to make sure that this is not executing if our character is no longer alive. So right here in some empty space, I'll create another custom event. I'll call it death. And the first thing I'll do on death is I'll set alive to false, like so. And I will also move up to the top here and I'll find an event begin play. If you're using an older version of the editor, you might find that this stuff right here is on event begin play. And if so, you'll just want to drag off of here and press S to get a sequence. And then you'll want to set up this logic off of here like so. But I'm just going to call event begin play and set it up here. But anything we plug in here, you'll just want to plug in off of this sequence if this is your event begin play, if you already have one. I do not in Unreal 5.5, so I'm going to grab event begin play here. And then what I'm going to do is grab my AC health system. And I can drag off of here and I can assign on death. And what this does is it creates this binding and it also creates a corresponding custom event like so. So I'll bind to event on death in my AC health system. And then on death event, we'll just call the death custom event that we just created. Nice. So now alive will be set to false when our character dies, because in our AC health system in update total health, we are calling on death right here if our health gets to 0. So now that means that you should not see the print string when this character dies. It will stop printing up at the top left. Very nice. So what we might do to make this death a bit more visceral is just ragdoll this character when he dies. So let's go to our death event right here. And the very first thing I'm going to want to do is turn collision off on the capsule component so that you can't collide with his capsule component anymore. So I'll grab the capsule component and I will set collision enabled to no collision, like so. I will also duplicate this node and I'll grab the character mesh right here. This will be the target, and I'll set collision on the character mesh to collision enabled query and physics. I will also set simulate physics to true. And I will also set physics blend weight to 1. And this is just very, very basic ragdoll functionality. I might add some reroute nodes here to keep this neat and tidy. And now when our character dies, they will ragdoll. Like so. Nice. And because we're using event point damage, apply point damage, this will apply some nice little physics to the ragdolled body when you shoot it. So you add some sound effects and some particle effects, and this would actually look quite nice. Cool. Alrighty. So that is just a very basic death function there. We're not going to do anything else with the death function, but we will be able to call this death event dispatcher from our actor component whenever we want in any part of the logic, and it will cause that character to die. Nice. So that's basically all we need to do in the character blueprint, because everything else we want to do is right here in our health system component. I'll disconnect this print string for now, but we might keep it to print some other stuff in a moment, because what we're going to do now is cause some damage to our limbs. And how we're going to do that is by creating a similar function to this, which will be update limb health, and we're going to pass through the physical material from the hit result. So we can drag off of the hit result here and break hit result, drop this down, and physical material right here, we can drag off of that and get surface type. And surface type is the custom surface types that we created, the head, torso, left arm, etc. So we can actually create a new function, and we'll call it update limb health. And update limb health will have a couple of inputs. Create an input. We'll call this one damaged limb. And this will be of type E physical surface. And we'll also pass through the damage. So damage, and this will be a float. Nice. Now just before we set up the rest of this function, let's call it in the event graph. So let's grab our update limb health, call it right here, and we'll pass through the damaged limb and the damage like so. Nice. Let's also give this a output. We'll call the output remaining limb health. Like so. And we can print this once we're finished setting this function up. We'll print it, and we'll print the actually what I'll do is I'll on the in string here get an append string, and what I will print is the limb that is damaged. I'll add another pin here, and I'll put a colon and a space, and then I'll print the remaining limb health. So this print string will tell us which limb has been damaged and how much health is remaining on that limb. Nice. So let's go back into this function and finish setting this up. We'll move the return node way out here, and what we'll do is we'll get our limb health, and this map, like I said, these are very, very easy to get your head around. Basically, to find the value at any of these keys, you can drag off of here and you can find, and then you just need a key, so we can pass the damaged limb to here, and now this will return the amount of health that that limb has stored in this map. So we can do this. Remember, this is how much health the limb has. Subtract, and we can subtract the damage. And let's also clamp this once again. This will be a clamp float, and I'll set it to the default value, the maximum, so that this cannot go below 0. And we'll get our limb health again, And then we will find a node called add. And this naming of this node is a little bit misleading, because you might think that this would add a new one right here. But actually, if you add at a certain key, it will just replace the value at that key. So it will set it, basically. So we can plug in the execution pin here, and we'll add the value at the damaged limb right here. So plug this in here. A couple of reroute nodes, and I might just move this down a bit. Keep it legible. And the output of this clamp float will go right here. So we're subtracting the damage from the limb health, and then we're basically setting the limb health as that. And that is basically it. We can plug this into the return node, and we can return the output of this clamp right here. And that's that. Very nice. So now, if I just make sure that we've plugged in the print string, yep, remaining limb health, very nice. This should all be working now, and you'll start to see this coming together. So if I shoot this character in, say, the left leg, up the top left, it will say left leg, 60, 40, 20, 0. And then we've killed them. Nice. And yeah, so that's all working. Torso, it is going straight to 60, which has me a little bit confused, because what's going on here? It seems to be subtracting the damage again from what has been set. So it's pulling this again after it's been set as 80, and reducing it by another 20 and printing that. So instead of passing through this result of this clamp, let's just get the find again right here, and we'll pass through that hit limb, and we'll just find that like so, and then that should be working correctly. So if we shoot the torso, we'll say torso 80, 60, shoot the leg, left leg 80, 60, right leg, that's all working correctly. Nice. Now, one more function I'd like to add to flesh out this system is an event any limb damage, so that you can set up basically something to happen whenever a limb is hit or, goes below a certain threshold. And I'm just going to duplicate update limb damage because it already has a couple of relevant inputs. So we'll just call it event any limb damage. Event any limb damage. And we can delete all of this. We'll delete the return node actually, and we'll get rid of that output. So we've just got the damaged limb, and we will call this input remaining limb damage. And once again, we'll make sure that we're calling this function right here. And we're passing through the surface type from the hit result and the remaining limb damage from the update limb damage, like so. So in here, if we drag off of damaged limb and we type switch, we can get a switch on E physical surface. And then if we drop this down, see we've got all of our custom surface types, and we can set up logic for whatever has been hit. So, for example, when your left arm has been hit, if the remaining limb damage is, less or equal to 60, maybe you want the left arm to be crippled or something like that. So I'm just going to do the head as an example. What I'm going to do is drag off of the remaining limb damage and get a less equal. And if the head damage is, if the remaining limb, sorry, this should be remaining limb health. My bad, guys. I'm confusing myself here. Remaining limb health. If the remaining limb health of the head is less or equal to 0, I'll drag off of here and press B to get a branch, plug in the head here, then I will call the onDeath event dispatcher. So I'll grab that and call onDeath, and because we've already set up to subscribe to this event, that will be working now. So if I hit play, we've got our different health damage to the different body parts. If I shoot the right arm here, it will say, oh, I got the left arm, right arm 80. And he's very close to death now, so it's not a very good test of the head health. But if I leave his health at 100 now and I just shoot the head, whoop, then that is causing death because we're taking 20 health off the head, and the default value of the head health was 20. And that's pretty much it, guys. If this tutorial has been of any use or value to you whatsoever, please hit like and subscribe, and I will see you on the next one.